Welcome. So today we're going to talk about hydrogen bonding, ionic bonding, and covalent bonding. Okay. So this is important as we've talked about atoms last class and the periodic table of elements, which I have right here. Today we're going to talk about what happens when two atoms come together. So remember, atom is the smallest basic unit of matter. You take that, you combine it with something else, it does something, it creates a molecule. So remember, it goes atoms, molecules, and cells. Okay. So today we're going to specifically talk about molecules and how they bond together. Okay. So when two atoms come together, they create a molecule. Okay. So today I want you to think about some molecules or compounds that we have on this earth. So what do you think the chemical name or chemical formula for water is? I'm going to give you a second to think about it. Right. H2O. So you've probably heard that before. What does the H mean though, and what does the O mean? So if we recall from yesterday, the H refers to hydrogen, and the O refers to oxygen. So in this case, what I want you to do right now, at the very top, I want you to write hydrogen bonding, like so. Hydrogen bonding. Okay. And remember, we're doing this on the bottom of the vocab on page 9. Okay, so what would you like you to write? Hydrogen bonding. Okay. Now, first thing we need to do is write out the formula. So H, okay, and it's 2. And don't worry about why it's 2 right now. Just know that to make water, you need 2 hydrogens. Okay, so we're going to put a 2 next to it. And you need an oxygen, like so. Okay. If you ever need to pause the video, feel free to pause the video. Okay. So before we do that, though, we need to do the Bohr model for hydrogen. So let's grab H here. So remember, the atomic number for hydrogen is 1. You can find that on your periodic table. And then the atomic weight is going to be 1.008. Okay? So we need to figure out the protons, the neutrons, and the electrons. Okay? So I represented that with P for protons, N for neutrons, E for electrons. Perfect. So next, how many protons? So we know the protons are the same as the atomic number. So we're going to put 1. Because atomic number is 1, protons are 1. Second, neutrons. So the neutrons, very simple. Remember, you take the 1 and you subtract it by the atomic number. Sorry, you take the atomic weight and you subtract it by the atomic number. So 1 minus 1 is 0. So for neutrons, we have 0. Now electrons. Remember, electrons are the negative charge. They're basically the opposite of the protons. So the protons are 1. That means electrons are going to be negative 1 or 1. Okay. So next, we need to do the oxygen. Okay. So over here, we do the oxygen. Okay. So oxygen has an atomic number of 8. If you look on the periodic table, the weight is 15.99, or we can round it to 16. Okay. 15.99. Right. Now, amount of protons is going to be 8 because of the atomic number. The neutrons are going to be 16 because we rounded 15.99. The closest whole number is 16. So we round that. 16 minus 8 is going to be 8. And then the electrons are going to be 8 as well. Okay. So now we've figured out the protons, neutrons, and electrons. Now we can create the Bohr model for these two. Quick reminder. Remember, H is going to be doubled. Okay, there's going to be 2 H's. So when we create our Bohr model, we're going to create 2 Bohr models for H. Now, I'm going to give you a second to write this down. You can pause it. I'm going to erase it, and we're going to move to the next part. Okay. Now, what we have here, so we need to draw H here. Oh, not H, sorry. Now we can draw. We're going to draw the Bohr model for H. So, how many protons were in hydrogen? We had 1. So P equals 1. How many neutrons? Let me make this a little bit bigger for you. Equals 1. neutrons, P. Okay. Oh, still not good. Hold on. I'm gonna make this so you can see. Okay. So P equals 1, N equals 1. Okay. So let's draw our nucleus. Okay. That's our nucleus. Okay. And then that's one hydrogen. So remember, it has an electron ring. And how many electrons does hydrogen have? 1. So just put 1 electron down here. Okay. There you go. All right. On this side, I want you to draw same thing, but for the second hydrogen. Okay. So P equals 1 in the middle. N equals 1. And then draw our electron ring. Okay. And then we put, because it has 1 electron, we're going to put 1 electron in its ring. Okay. So we should have the same things drawn here. Now y'all can draw much more neater than mine, so your circles are hopefully a little bit more neat. Now, so we can put an H in here just to let us know that these are hydrogens. Okay. Okay. So we have 2 hydrogen molecules. Okay. But to make water, what does it need a bond with? Correct, oxygen. Very good. So for oxygen, what we're going to do is we're going to draw the Bohr model for oxygen. So we know the amount of protons, right? How many protons do we have? 8. Good. So right down here, you're going to write P equals 8. How many neutrons do we have? 8 neutrons. Very good. So N equals 8. Okay. Now, we need to create the Bohr model for this. So remember, a Bohr model, this is simple. We did it with the hydrogen. When you're looking at a microscope, very, very zoomed in, this is what you're seeing on these molecules. You're seeing the nucleus, and you're seeing an electron ring. Okay? So the electron ring is important. I'm going to explain why. It kind of wants to be at a certain spot. It wants to feel good all the time. And I'll explain how. Okay? So what happens is we first need to draw the oxygen Bohr model. So we have the protons and neutrons. Now, it has 8 electrons. So we need to remember that the first electron ring can only fit 2. Why can it only fit 2? So let me show you. So looking at the periodic table, okay, do we see period 1? So period 1 is right here. So in period 1, there is 1 and there is 2. There's only 2 elements in period 1. Okay, there's only 2. So that means that ring, the first ring, can only fit 2. Now, the second period, right here, that would be the second ring. But it can fit more than 2, correct? How many can it fit? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8. So it can fit 8. So we need to remember that in order for an atom to be content and happy, its ring needs to be full. So far, in the first ring, we're going to put 2 electrons. So this ring is happy. It's full. Okay, it can't fit anymore. So what do we need to do? Correct. We need to make another ring. So here's another ring. Okay. Now, how many more electrons do we need? For oxygen, how many electrons does it have? 8. Correct. So if it has 8, we just need to draw how many more if we have 2? So 8 minus 2 is 6. So we need to draw 6 more. So 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here. 1, 2, 3, 4, 5, 6. So I have 6, okay? But is my electron ring full? How many can you fit on for the second ring? Remember, 1, 2, 3, 4, 5, 6, 7, 8. You can fit 8, but I only have 6, so I need 2 more. Now, let's look at the hydrogens. So their ring, they have an extra one, okay? They have one that they can give. How many do we need? 2, correct. So all I'm going to do is I'm going to move an electron over here. I'm going to move an electron over here. Now let's count the outer ring. How many does oxygen have now? 1, 2, 3, 4, 5, 6, 7, 8. Has 8. Is it satisfied? Is it full? Yes, it is. So you've seen that these created a hydrogen bond. So when you're friends with someone, you have a bond between them. Think about water like this. The hydrogens bond together with the oxygens to help them out. And now they're a unit. Now they're together. They're a friendship, H2O. Okay. So that is hydrogen bonding. Next we'll go on to ionic bonding.